Hello, everyone. Thank you for joining us. We would dive straight into our project and the agenda. Our project is activity recognition classification. So, the agenda would be I would introduce the team and who has particularly done what work in the project. I'd explain what is the project motive. Furthermore, my teammates would carry the part of explaining how they have acquired the data set and what and the structure of the data set, the logical approach that we have followed, the logic behind choosing the output, and also the challenges that we face throughout. So here is my team. My name is Himanshu Sharma, and I have helped in acquiring the data set. We have Simran Agichani, who has helped us in data preparation. We have Priyam, who has helped us in data visualization. We have Nandini, who has helped us with data modeling. And we have Shov with us, who has helped us in model interpretation. So, explaining about the project and the motive behind this project, our project revolves around tackling classification tasks through predictive analysis on WSN data, which is wireless sensory network data. We aim to decipher intricate patterns within the data set to classify the user activity, such as bending, sitting, cycling, etc. And we have done this through the AREM data set. So the ultimate goal for this project is to pave the way for applications that go beyond data analysis and offering personalized user experience and optimized system response. The further explanation would be taken up by Simran for explaining the data set. Thank you.
Hi everyone, my name is Simran, and for our project, we have selected the dataset that is the activity recognition dataset. The link to the dataset has been given in our presentation. So I've already opened the link here. Uh, so this is the activity recognition system dataset that we have selected, and it is collected from a wireless sensor network device worn by an actor performing various activities. It is a time series data, but for our purpose, we have dropped the temporal variables since our purpose is classification. So our task is to predict the activity performed by the user wearing the device. We have collected the received signal strength data, that is the signal data using the iris nodes. So the device is placed on the user's chest and ankles, and the nodes selected are the chest right ankle, chest left ankle, right ankle, left ankle, and five samples of RSS data for each of the three couples of the wireless network nodes are selected. And the variables that we have in our dataset are the mean and variance of these nodes of the RSS values corrected from these nodes. So for exploratory data analysis, I'll walk over through the data gen file, that is the data prep file. So for our exploratory data analysis, we have created two plots, the box plot and the data distribution. So we have created this box plot to see the spread and the variability of the values in the mean and the variance of the RSS values. And the data distribution uh, shows that the histograms of the uh, mean values of the RSS values are all seem to be normal. And from here, we can conclude that our data is pretty clean for and ready for modeling. And now I'll hand over to Shov uh, to explain and give a walkthrough over the code. Uh, thank you.
Hi everyone, I'm Nandini. Now that we have a clear understanding of our project motive as well as the data set, I'll now walk you through the logical approach that we have taken. So the first step is data acquisition. So we have streamlined the process of sourcing and importing the data using Python. And then we have merged different data sources and then done the pre-processing. So we clean the data set to ensure quality and consistency. And then we have done data visualization to uncover any patterns and get some insights. And after that, we have done data partitioning where we have segregated our data into training and test set for our model validation. And then we have done model development where we have implemented decision trees, random forests, and multi-layer perceptrons for classification tasks. And then afterwards, we have configured our pipeline in PySpark where we have set up data transformation and modeling our training workflows. And then we have fine-tuned our model parameters and fitting to the training data for model training. And then we have done our model performance evaluation where we have assessed accuracy, precision, recall, and F1 scores. And then we made predictions by applying trained models to test data for activity recognition. And finally, we have analyzed our results and compared our model outputs. So this data flow is the exact representation, the diagrammatic representation of what we have just talked about. So basically, it's the first step is sourcing data in Python, and then we have merged and cleaned our data, visualized it, split our data into training and test set, and then we have used our classification models. Later, we have set up our pipelines and we have done our model training as well as comparison of the results. Now, our teammates will take over and talk in detail about our code base, the outputs and challenges. Thank you.
Hi, my name is Shubhranshu. I'm here to talk about the code walkthrough and at a very high level, and I will be demonstrating the execution end result as well. So as you can see on the screen that we have the data loaded using the data gen.ipynb file, and I have included all the necessary PySpark libraries as well. We have done some sort of PySpark to continue with the EDA and modeling, and I'm sure Simran would have shared which have showed the visualization on the notebook as well. We have pre-processed the data, checked if there is any null available or not. Then we had to check if we have anything called any non-required column. So we have dropped columns time, which is not required in this particular case because this is a very simple classification problem. I would be skipping this and let's. I have saved our data, which we'll be utilizing in our model fitting, and I will be reading this data in our model fitting notebook. I've created this model fitting notebook to keep the things separate, where I have one notebook to save the data, clean it, and show the visualization as a part of exploratory data analysis. And the second notebook is basically to experiment with models and select the best models. So here we have initialized the Spark session. As we can see on the screen that we have 1, 2, 3, 4, 5, 6 sensors, and then we have the labels as well. I checked how many labels do we have. We have 6 labels as well, and it is fairly a balanced data except for bending. However, we could have done some sort of smooth analysis as well, but then I figured that it's not a huge imbalance, so we went ahead with our models. So we have used 3 models here. One is decision tree, the second one is random forest, and the third one is multi-layer perceptron. For decision tree, we have used pipeline and assembler along with label indexer. Here, if you see, I have the accuracy, the F1 score, the recall, and precision as well. Same, we have done the similar practice for random forest. We have the model name, accuracy, F1, recall, and precision, and the same for multi-layer perceptron. At the end, we had to figure out which model was performing the best, and we figured out that the performance and as per the performance analysis, that MLP model has the lowest accuracy and F1 score among the 3 models, indicating it might not be the best choice for this particular data set. And for we selected random forest as it had the highest F1 score. And why I selected F1 score is basically F1 score gives us how we calculate F1 score is basically it is the harmonic mean of precision and recall, which makes it suitable choice for binary or more than 2 classes classification. Now let's go back to our presentation and let's discuss some of the outputs. In activity recognition applications, identifying both positive and negative instances is very important. And the F1 score, since I've already told that F1 score is harmonic mean of precision and recall, which makes it suitable choice for any kind of classification task. We have selected the random forest model achieving an F1 score of 67.16%, which stands out as the optimal choice for this classification task due to its robust performance. My friend Priyam will be going ahead and talking about the challenges we faced during this project. Thank you.
Uh, Hello, my name is Priyam and I'm part of this Big Data Project team. So, today I'll be talking about the challenges that we faced while working on this particular project. For this project, we majorly faced two challenges, which were data sourcing and data merging. We face difficulty in acquiring a high quality, consistent data from diverse sources, since different sources tend to have different level of data quality and consistency. And after that, after acquiring our dataset, we face difficulty in integrating multiple datasets with varying formats and standards. Since merging incompatible dataset with different formats might lead to inaccuracies and inconsistencies, which might pose a risk for our overall outcome. To tackle these challenges, we implemented two solutions. Let's talk about those. To address the issue of data sourcing, we implemented selective data acquisition, and for that, we implemented strict criteria for dataset selection to ensure the quality and relevance. We meticulously evaluated the data sources and data sets to prioritize the quality and relevance. And to address the issue of data merging, we developed a standardization pipeline. We aligned the data schemas for consistencies and normalized the different sampling rates for comparability. We also conducted rigorous quality checks post merging to look for any inconsistencies or error if still there. And after implementing these two solutions, we were able to create a unified high quality data set for our accurate activity recognition. And getting this high quality data set helped us significantly improve the reliability of our results. Uh, this is all for our presentation today, and I would like to thank you for being here with us. Thank you so much.